Hello and welcome to the next learning target, which is about bond energy in organic molecules. So this is learning target 3.3 for Southeastern and Unit 2. Our goal for today is that you can describe the relative energy contained in the bonds of different organic molecules. So by now we should know pretty clearly what organic molecules are. Let's talk about what gives these molecules energy. So, just a little review, but this should go in your notes. Chemical bonds are connections between atoms. So we can see here H2O, right? One O and two H's. That's H2O. We have oxygen here and then hydrogen attached to it. The attaching bond here, that's called a chemical bond. So this line, we draw the symbol here that represents a chemical bond. So a chemical bond, again, is just a connection between atoms. So we have two bonds in H2O. When we build bonds, it requires energy. When you put more than one atom together, it requires energy. And if you had chemistry before, or maybe you remember back to middle school, any reaction that requires energy is called an endothermic reaction. A great example of this is actually photosynthesis. So we'll be learning about that more later, but look at this equation. It's pretty simple. You have carbon dioxide plus water, and you input light, which in this case is sunlight, and it makes sugar and oxygen. Alright, so this is a reaction that builds bonds. Look at this. This is glucose right here. So this is that sugar molecule. These are all carbon atoms connected with oxygen atoms and hydrogen atoms. Look at all of the chemical bonds here. This is sugar. So we have, you could count them up, 1, 2, 3, 4, 5, 6, 7. There's a lot of bonds. Anytime you see a line here, there's a bond, and all of those bonds represent more energy that is trapped in that molecule. So as you probably already know this, when you eat sugar, you get a lot of energy because of all the bonds that are in sugar. Alright, so energy is stored in these chemical bonds. So energy is stored in chemical bonds. Alright, here's another molecule. This is a long carbon chain. Any guesses as to what the name of this molecule is? So there's actually 8 carbon atoms. You might call this octane because it has 8 carbon atoms and hydrogen atoms. So it's gasoline. Can you count how many bonds are in it? So go through and count. I'll give you a few seconds here. Each one of these bonds, each line between each atom represents a new bond. So if you've counted them all up, you should get to about 25 bonds. So each one of these atoms is connected to another atom. That connection is a bond, a chemical bond. So as you probably already know, gasoline, or octane, has a lot of energy. All right, so when a bond is broken, when we break that bond, energy is released. So you know, you burn gasoline, you're breaking bonds and releasing energy. Looking at the reverse of photosynthesis, this is called respiration, right? You eat sugar, you breathe in oxygen, you break the bonds in glucose, and you release carbon dioxide and water, and you also release a lot of energy. So in our bodies, we use an energy form called ATP, but that release of glucose, the release of the bonds, releases energy. And as you might have remembered from chemistry or middle school, when you have a reaction that releases energy, that's an exothermic reaction, meaning a release of energy, an exit of energy. So here looking at this flame, another example of a gas burning, that is a release of energy. So some bonds contain more energy than others. You probably kind of could have figured this out on your own, but different types of chemicals have different amounts of energy. So we have all different types of chemical bonds here. Look at this chart for a few seconds. We have what are called single bonds. So this little bond here represents a single bond, so one bond between carbon and hydrogen, or oxygen and hydrogen. See which one's the highest there. Now over here we have double bonds. Alright, so can you tell which type of bonds have the most energy between single bonds, double bonds, and triple bonds? Right, so we're looking down here. These have the most energy. These are actually in calories. So these are calories per mole. So calories are a form of energy. So if you didn't get it, it's triple bonds. Triple bonds have the most energy. Energy increases as more bonds are formed. We just went over that, right? So you understand that as you have more bonds, there's more energy. So it makes sense then that when there's 3 bonds between carbon and nitrogen, there's more energy. So there's more energy in CO, which has 3 bonds in it, than just CO, which has 2 bonds, or CO, which has 1 bond. It almost, I mean, it does, it doubles every time. So you can add them up to get to the bigger amount of energy. All right, and that's it. That's the end of our presentation on how much energy is in the different types of bonds. So remember, chemical bonds store energy. It takes energy to create a bond, and it releases energy when you break a bond. That's about it. Thank you.